Hi guys, so sorry I'm unexpectedly out today, but we're going to go on to this next section. This next section talks about writing polynomial equations. So we spent a lot of time now, if I give you the equation, you finding the solutions, whether that was by factoring or whether that was by using the calculator and some other algebraic techniques. But right now we're going to work backwards. Either I'm going to give you a graph or I'm going to give you some information about a function, and I want you to be able to work backwards and write the equation. So I know this is a warm-up, but we'll kind of go through this together. Looking at this graph, you've seen these graphs before. We've done this last week. So that first question, identify the lowest possible degree of a function. Hopefully you remember what that means. If you forget for any reason, the degree is the number of turning points plus 1. This function has 2 turning points, so its lowest possible degree is degree 3. Now, the y-intercept. Y-intercept is something I think you understand. We haven't really talked about that lately, but I think you know the y-intercept is where the graph crosses the y-axis. So for this particular graph, that would be at the point 0, -6. And I do want you to write that as a coordinate, not just a number. Now, identify the zeros. We've done this. We've done this on the calculator. Okay, you can see that this crosses at 3 times on the x-axis, so we have the 3 zeros. And this crosses at nice whole numbers. These 3 zeros are at -3, or x equals -3, -1, and +1. As always, the order that I write these does not matter. Okay, and then when you go to write things in factored form, we've talked about this. The relationship between the factors and the zeros are that they're opposite. So when I go to do that, that a is the lead coefficient. Up until now, we've only talked about the sign of the lead coefficient. For instance, looking at that graph, you should know the last thing that graph does is go up. So the sign of the lead coefficient is positive. But in this process of writing the equation, we're going to be able to find out the actual numeric value of the lead coefficient. Okay, back to writing the factors. If there's a 0 at -3, there's a factor at x plus 3. If there's a 0 at -1, there's a factor at x plus 1. And if there's a factor at +1, or I'm sorry, a 0 at +1, there's a factor at x minus 1. Now, to help us find out what a is, and again, its actual numeric value, not just its sign, we are going to use that y-intercept. And we can always use the y-intercept as long as 0 is not one of the solutions to the equation. So I'm going to treat that y-intercept, reminding us again that that is at the point 0, -6. So 0 is my x value, and -6 is my y. So I'm going to go to standard form of the equation, and for any and all x's, plug in 0, and any and all y's, plug in -6. So instead of y, I'm going to have -6 equals a. Instead of x's, I have a 0 plus 3, a 0 plus 1, and a 0 minus 1. I can simplify all those sets of parentheses on the right. 0 plus 3 giving me 3, 0 plus 1 giving me 1, and 0 minus 1 giving me -1. We should know that all those parentheses on the right mean to multiply. If I multiply all those numbers together, I get -3, so I'm going to call that -3a. I hope at this point we can solve. Divide both sides by -3. So a, or my lead coefficient, is +2. So now instead of just knowing that my lead coefficient is positive, I can actually tell you what its numeric value is. So putting this all together in the equation, my equation then for this polynomial is y equals 2 is my lead coefficient, and then my factors, x plus 3, x plus 1, and x minus 1. This is the equation in factored form. We can also talk about the equation in general form. In general form, I would have to multiply all these out to get the expanded value of this function, and I can do that. It just takes us a little bit more time. So I wouldn't do that unless I specify. Okay, looking at, again, there's some steps. Identify the zeros either from a graph, or I can give them to you. Write those zeros or roots as factors. Use an additional point for x and y, whether it's the y-intercept or another point. Find a, and then at the end, write the equation together. So again, let's kind of roll through this again. This time, instead of me giving you a graph and asking you to pick the zeros and the y-intercept off of the graph, I just gave you all the information. And it says we want to write the equation in factored form unless specified. So I'm going to start. If I know there are 3 zeros, I know this is a degree 3. And if I write this in factored form, it's going to look like y equals, I don't know a yet. A 0 at -4 gives me a factor of x plus 4. And we talked about that when we started this solving stuff on Wednesday. A 0 at -2 gives me x plus 2. And a 0 at +1 gives me x minus 1. Then I'm going to take that ordered pair. It happens to be the y-intercept, but it could really be any point on the graph, and use its x and y value. My y is 16. All those x's, I'm going to plug 0 in for every single x I see there. Then I need to simplify those sets of parentheses. 0 plus 4 is 4, 2, and a -1. I have to multiply all those things together. 4 times 2 times -1 gives me -8. Divide both sides. This Lie coefficient is a -2. Now again, I need to make sure that I actually write the equation. Just finding the Lie coefficient is important. I need to do it, but I need to pull it all together at the end and write the equation. So this equation would look like y equals a Lie coefficient of -2, and then include all your factors. X plus 4, x plus 2, and x minus 1. Remember, factors are things with x's. They are not at the point where you plug in all those zeros. And because I didn't specify anything else, I would leave it in factored form. It's always easiest for us to leave in factored form. If I expand it to general form, we can do it. It just takes a little bit more time. Okay, look at number 2. The big thing I want you to notice on number 2 is it says there's a 0 at -3 and it says double. Sometimes you might see me abbreviate that as DR, meaning double root, or sometimes you might see me say a multiplicity. That's a fancy word, a multiplicity of 2. That means that 0 is repeated twice. So if this is a double root at -3, that means -3 appears twice. So pause the video for a second, see what you can do with that one. Okay, let's see how we did. So because there was a double root at -3, that factor appeared twice, so I used x plus 3 twice. You could have also said x plus 3 squared. And then there was another factor at +2, or a 0 at +2, so the factor was x minus 2. I used the y-intercept for my x's and y's. The a value in this case was +1/3. Don't give me the decimal because it's not a terminating decimal. Keep it as a fraction. Now, my final equation at the bottom, I wrote it 1/3 x plus 3 squared and x minus 2. If you wrote out x plus 3 twice, that's 100% fine. Okay? Let's move on to that bottom one. So the only difference with the bottom one is it says write the polynomial in general form, meaning this one, unfortunately, is going to have to be expanded. Okay? So it starts out the same way as it did before. We're going to start with, I don't know the a value, and I need all the zeros. So if there's a 0 at -2, there's a factor at x plus 2. If there's a 0 at 0, its factor is just x. I mean, you could say x minus 0 or x plus 0, but that's not going to change anything. If there's a 0 at +2, the factor is x minus 2. Now this time I used a different point instead of the y-intercept. It's totally fine. It's still an x and a y value. The reason why I had to use a different point, to be clear, I can always use a different point, but I had to this time because 0 was one of my solutions. So this time my y value is -30. My x value every time is 3. Even though it's not 0, it's still the same as before in terms of simplifying. Meaning 3 plus 2 is 5, then I have a 3. 3 minus 2 is 1. It's still about multiplying those things together, which gives me a positive 15. And still about finding A, which is negative 2. Now, when I go to write this equation, it starts out the same way I did before, meaning I'm going to start out with y equals, I have negative 2. That lone x I'm going to put in the front, and then use the x plus 2 and x minus 2. Okay, now if this hadn't specified this general form right here, I'd be done. Because it says general form, I have to keep going. And what I mean by that is I have to distribute this and multiply this all out. So I'm going to start and distribute that negative 2x to the first set of parentheses, which gives me negative 2x squared minus 4x. I still have that x minus 2. Now I have to take that and multiply that answer, that negative 2x squared minus 4x, to the x minus 2. So that gives me negative 2x to the third, a positive 4x squared, a negative 4x squared, and a negative 8. Okay? Combining my like terms in general form, this looks like negative 2x to the third. The x squareds cancel. And I'm left with, oh wait, that last term should be positive 8x, my bad. So plus 8x. Okay, so this is this equation in general form. Now, if you ever want to check that to see if it's correct, you can go to your calculator. You know some things about this function. It should cross the x-axis at negative 2, 0, and positive 2. So you can go to your calculator. And plug in what I think this equation is. So we think it's negative 2x to the third plus 8x. And graph this. And we know that there should be zeros at negative 2, 0, and positive 2. It looks like that, but I could always go to my table to verify. Yeah, yes, there's a 0 at negative 2. There's one at 0, and there's one at positive 2. So when you're writing these equations, you can always go back and plug them in the calculator if you want to check to see if this works. Okay? All right, so if you flip over on the back, it starts to talk about some solutions that have i's, or imaginary numbers. I am going to do that, but my video only allows me to do 15-minute increments at a time. So I'm going to do the back side of the notes on part 2 of the video.